In this video lecture, I will demonstrate you how to write an 8051 C program to transfer a character A serially at 4800 baud rate continuously. In short, this is a program for serial transmission. And what we have to do? We have to write a program where a single character A would be sent out of microcontroller over TXD pin. As we already know that 8051 supports serial communication. It means that it can support serial transmission and serial reception as well. As far as transmission is concerned, TXD pin is there, which is meant for transmitting data serially, and this TXD pin is the alternate function of P3.1 pin of microcontroller. When you want to send the data serially out, that data is to be sent out on TXD pin, and that data is to be sent at a baud rate of 4800. One more thing is that data is to be sent continuously. Means when you send a single character A out, then again you have to send the same character A. Again you have to send the same character A. So this is to be done in a continuous fashion, and the speed at which this serial transmission is to be carried out, it is 4800 baud rate. So for writing the program, we will first go through the algorithm. Means what steps we need to follow while writing the program. The first step is timer plays an important role in serial communication. So we will first set timer 1 of 8051 in mode 2, because whenever you want to have a baud rate according to your choice, then you have to use timer 1, particularly timer 1 of 8051, and that too in mode 2. Now how to set a timer 1 in mode 2? For that purpose, Tmod register should be loaded with appropriate value. So this will be the first thing that we will do. Then what about the baud rate? I am being asked to send the character A at a baud rate of 4800. For that purpose, through formula, I will calculate one value, and that value will be loaded in TH1 register of timer 1. I already have told you that timer 1 is used. Timer 1 has two registers, TH1 and TL1. Out of that, as mode 2 is 8-bit mode of timer, only TH1 is used for the baud rate selection. So timer mode is selected in first step. TH1 is loaded with a particular value in second step. Now we will load SCON register with a value to set mode 1 of serial communication. As timer operates in 4 different modes, similarly serial communication also can be performed in 4 different modes. Out of them, we will concentrate mainly on mode 1. Mode 1 is 8-bit UART mode of serial communication. In order to set 8051 in mode 1, we have to take the help of one more SFR, which is SCON, that is serial control register. Then we will start the timer. By default, timer is in stop condition. Then we will start the timer, and immediately after that we will send a character A to SBUF to transmit it. Now what I have told you, that we use TXD pin of microcontroller to send data serially out of it. Before sending the data over TXD pin, we should first load the data in SBUF, that is serial buffer register of 8051 microcontroller. Once you load the data in SBUF register, that data will be sent over TXD pin 1 bit by 1 bit, because we are talking about serial communication. So A is having 8-bit ASCII code. In mode 1 of serial communication, we use one start bit, 8-bit ASCII code of that data to be sent, and one stop bit. So in total 10 bits would be sent one after another over TXD pin. So for that purpose, we have to first load the data to be sent in SBUF register, so that data will start transmitting 1 bit by 1 bit. Now how we will come to know whether all 8 bit of data are sent or not? For that purpose, 80 provides the facility of TI flag. TI flag means transmit interrupt flag. If the status of that flag is 0, it means that the data which you have just sent, it is still going out serially. In other words, I can say that if TI flag is 0, it means that the process of serial transmission is still on, it is not completed. So what we have to do? We have to wait. And what time we have to wait? We have to wait until TI flag is high. It means that when start bit is sent out, it is followed by 8 bit of data, and when stop bit is sent out, then TI flag becomes high. So when TI is low, it means that sending process is still on. When TI is high, it means that all 8 bits of data, they are sent out. Once we are sure that TI flag is high, then we have to clear the flag. Why we have to clear the flag? Because in second step we have to send the same character A for second time. For that purpose, we have to first clear the TI flag, and then we will repeat the whole process by going to step 5. So these 3 lines, step number 5, 6, 7, they are to be repeated forever, because we have to send the character A continuously. Now let us move to the programming part. The first step is inclusion of reg51.h header file. Now what is the role of this header file? This header file stores the definition of all special function registers of 8051. If you include this header file in your program, and if you write the names of special function register, like in my program I am going to write the name tmod for mode selection of timer, th1 for baud rate selection, scon for mode selection of serial communication. So all these registers definition, they are stored in reg51.h. So it should be loaded. It is followed by writing the main function. This curly bracket indicates that main function is going to begin. It is followed by the first thing, that load tmod register with the value 20. 0x means 20 is in hexadecimal. What does this step do? This step will store or load 20h in tmod register, so that timer 1 gets set in mode 2. Actually it is mode 2, not mode 1. So timer 1 is set in mode 2. For that purpose, you should have the knowledge of tmod. So what is tmod? The format of tmod looks like this. The first 4 bits, gate, C/T bar, M1, M0, these are meant for timer 1, and remaining 4 bits, again gate, C/T bar, M1 and M0, these are for timer 0. As I am not using timer 0 in my program, I will set lower 4 bits to 0000. In serial communication, particularly timer 1 is used, and these 4 bits are used for setting the mode of timer 1. What about gate? Gate is used when you want to control the timer through hardware as well as software way. I don't want to control the timer through hardware, so I will make gate as 0. C/T bar is to be used when you either want to use timer as a timer or you want to use timer as a counter. As I am not using timer as a counter, so I will put it as 0, because when 0 is put, timer acts as a timer. If I have put here 1, then it would have been in counter mode. So I have put 0 so that it works in timer 1 and it will generate baud rate for serial communication. M1, M0, these are the mode selection bits of timer. Each timer of 8051 works in 4 different modes. Those are mode 0, mode 1, mode 2, mode 3. Particularly for serial communication, we set timer 1 in mode 2. So in order to set timer 1 in mode 2, M1 should be 0 and M1 should be 1 and M0 should be 0. So that timer 1 gets set in mode 2. Now make group of 4 bits and replace it with hexadecimal number. So 0010, it is 2 in hexadecimal. Similarly 0000, it is 0 in hexadecimal. In other words, I can say that when I load tmod register with 20h, timer 1 is configured in mode 2. So that's why I have loaded here tmod with 20h. Now what is the next step? Next step, is load TH1 with some appropriate value which will be responsible for setting the baud rate of 4800. I have loaded TH1 with the value FA. Now why FA? Again we will go to the explanation part. In order to set the baud rate of serial communication, we have to go through one formula, and that formula is what? A baud rate is equal to 2 raised to s mod into oscillator frequency divided by 12 into 32 into 256 minus TH1. For 8051, I have taken the crystal frequency as 11.0592 MHz and s mod is a bit of peak-on register. If that bit is 0, serial communication is performed at normal rate. If that bit is made 1, serial communication is performed at double baud rate. I don't want to go for double baud rate. That's why s mod is kept as 0. Now replace these values in the formula. So s mod is 0, so 2 raised to 0 into f oscillator is 11.0592 into 10 raised to 6 divided by 12 into 32 into 256 minus TH1, and 4800 is the desired baud rates. Once you solve this, you will come to know that the TH1 has the value of 250, and when 250 in decimal is converted into hexadecimal, it is FAH. FAH is written as 0xFA. The same is the notation for the hexadecimal. It means that TH1 register should be loaded with FA value so that a baud rate of 4800 is generated. Hence, this FA is loaded in TH1. So, timer part is now over. Now, what is the next thing? Next thing is serial communication mode to be set, and for that purpose, one more SFR is there, which is SCOM, and this register is loaded with 50H. Out of 4 modes of serial communication, we are using mode 8, which has variable baud rate. Variable baud rate means I can set the baud rate according to my choice, as I have just set it 4800 by loading FA. And this is 8-bit UART. Now why I have taken 50H value? Again, we will go to some calculation part. And for that purpose, we need to have the knowledge of SCON register, which is serial control register. SM0 and SM1, these two bits of SCON, they are responsible for setting mode of serial communication. I want to set microcontroller 8051 in mode 1 of serial communication, and for mode 1, SM1 0 should be made 0 and SM1 should be made 1. SM2 is for responsible for multiprocessor communication. I don't want to do it, so I will put 0 here. REN is reception enable. If it is 1, reception is enabled. TB8, RB8, these are the bits which are used in mode 2 or mode 3. I will put them 0. TI and RI, these flags are automatically set when transmission is completed or reception is completed. So I will make them 0, 0. Again, make group of 4 ones. 0, 1, 0, 1 correspond to 5 in hexadecimal. Similarly, 0, 0, 0, 0, it is 0 in hexadecimal. So SCON should be loaded with the value 50H. So that's why I have written 50H, because 50H loaded in SCON will set mode 1 of serial communication. So you are done with the mode of timer, you are done with the value in TH1 responsible for 4800 baud rate. Serial communication mode is also set. Now it's time to start the timer, and timer is started by making TR1 bit as 1. TR1 is timer run bit of timer 1, and when this bit is 1, timer will start ticking, it will start working. Now what is to be done? I have to send capital A over TXD line, and I have to do it continuously. In order to do a particular thing continuously in C program, we have to write that whole block of code in while 1. While 1 means repeat forever. While 1 means repeat forever. What is to be repeated? First, I have to send a character A to SBUF register, and I have already explained you. Whenever I am sending any character to SBUF register, it goes out of TXD pins. Means the ASCII code of A will start going out over TXD pin. I have to wait until all bits of A are sent, which is followed by stop bit. And for that purpose, I will take the help of TI flag. When TI flag is 0, what I have to do? I have to wait. So while TI double equals to 0, semicolon, it means that keep the program in this loop. This is a single line loop. If the value of TI flag is 0, TI is 0, it means that your data is not completely sent. It is still in process. So wait. Again check it and again wait if it is 0. So repeat it till TI becomes 1. And once all 8 bits of data are sent over TXD line and stop bit is sent, TI flag becomes 1. It means that capital A is now totally sent out. Now come out of the loop and clear the TI flag, because we want to repeat it one more time continuously. I have to repeat it continuously. So TI flag is cleared, and now from here program will go to while 1. While 1 is always true. Again it will send capital A for second time to SBUF. It will wait until total 8 bits of capital A are sent. Once all 8 bits are sent, the TI flag is cleared. Again it will come to while 1, and this whole processor will repeat forever. It means that 8051's TXD pin will transmit capital A serially in a continuous manner. Continuous manner means once it is sent, again it will send it one more time, again it will send it one more time. Now we will simulate this program by using kill ID. I have already developed the program in kill ID. The same program which I have just explained appears here. Let us save the program. Let us click the build target, and at bottom you will find that my program contains no error. Now it's time to start the debug session. So start stop debug session by clicking debug menu and start stop debug session. Now where you will going to observe the output? I am going to observe the output at the bottom right corner where UART #1 is written. Means this is the serial one window. If this window is not visible in kill ID, then you have to go to view menu, and in view menu you will find that serial window option is there. Under that click UART number 1. So this window appears here. I have not run the program yet. Now what I am expecting? I am expecting that the data which is sent over TXD pin of microcontroller should appear here after I run the program. So I will run the program by clicking the debug menu and by hitting the or clicking the run button. As I have clicked the run button, you can observe that this capital A is being sent continuously one after another. So it is going on continuously. So whole serial window is occupied with capital A. So in this way, the serial character A is sent continuously. Now let us stop the program and let us come out of the run window by clicking start stop debug session. So just we have learned how to send a single character continuously over the TXD pin of microcontroller. Now this program is to be modified, and what I have to do? I have to do a slight modification in my program. And what I have to do? Now I have to write a C program to transfer the string. Instead of a single character, I have to transfer or transmit 3 different characters. Those are yes. Yes is a string, and they are to be sent at a 9600 baud rate. Means I have changed the baud rate, and again the same thing is to be repeated continuously. Now what is the change between this program and the program which we just developed? The change is that instead of a single character, I have to send a string of character or collection of character. These are the 3 characters. So this is the one change. And second thing is, I have changed the baud rate from 4800 to 9600. We will modify the same program in key. Now the first thing, that whenever you are dealing with more than one character, it is always a good practice to store those characters in an array. So in C program, I will declare a variable unsigned character. Number of characters that are to be sent are 3. So I will declare the size of array as 3, and by inserting the string yes in double inverted comma, I will store the string in an unsigned character. But I have forgotten to name the array. So I will name the array as message, MSG. Again I am repeating. Unsigned char is the data type because each character has are in the form of ASCII code, are to be sent in the form of ASCII code. So unsigned character data is selected. MHG is the name of the array, and square bracket holds the size of the array. Size of the array is 3 because 3 characters are set. If you don't know the size, you can put these brackets empty also. So that is also allowed. So first thing what I have done, I have stored the string in memory of microcontroller. And what I am going to do, I am going to do the sending part one after another. Means initially Y will be sent, it is followed by E, it is followed by S. So for that purpose, I have to take each character through this array one by one, and for that I will require the help of one more variable, unsigned character, and I will name it as I. The first thing, tmod is loaded with 0x28, it remains same. Timer 1 is configured in mode 2. th1 is loaded with fa because initially I had to send it through 4800. Now in this program I have to change the baud rate as 9600, and if you use that formula, then for 9600 you will find that the value is fdh. Now the calculation part can be done at your own. So th1 is loaded with fd. You can use that formula, put the values, you will get the value fd. Again scon is to be loaded with 50h, so that mode 1 of serial communication is selected. Timer 1 is started by making tr1 bit 1. I have to do it continuously, but I will first explain how to send yes only once. Sending yes is a process of repeating the 3 steps. First send capital Y, then send capital E, then send capital S. Means I have to send 3 characters. So one activity is to be repeated 3 times. That's why I will mention that activity, or I will write that activity in a for loop. And that was the same purpose by which I have declared the unsigned character I variable. So that I variable will be used here. I is equal to 0 because inside the MSG array, capital Y is stored at a 0th position. So I have loaded I with 0. Then how many characters you want to send? You want to send the 3 characters. Y is stored at index 0, E is stored at index 1 in the array, and S is stored at index 2 of array. So I have to go on incrementing the value of I till I reaches 2. So the condition I have set is I less than equal to 2, and each time I have to increment the value of I so that next character is sent. So this loop will get executed 3 times. Now what is to be done? Initially first character in an array is to be sent. So I am modifying the last program, remember that. So I am deleting the unnecessary part and I am modifying. So sverb is to be loaded with the first character in array. Now I variable is used to point to the characters. Initially I is made 0, means now currently the value of I is 0. So as I is 0, mhg0 is the value of this sentence. mhg0 means the character stored at 0th position of mhg array. Which character is stored? Y is stored. So Y will be sent to sbuf. Then it will check whether all 8 bits of capital Y are sent or not. If not sent, it will wait here, and then once all 8 bits of capital Y are sent, that flag is cleared. From here the program will come to the for loop and value of I is incremented by 1. Initially I was 0, now I becomes 1. Is 1 less than 2? No. It will come inside the loop and it will execute this statement for second time, but now the value of I is 1. Now value of I is 1 means I am sending the character stored at index 1. Which character is stored at index 1? E is stored. So capital E is now sent to SBUF. Wait until total 8 bits of E are sent. Then once all 8 bits are sent, clear the flag and go one more time to the for loop. Now value of I becomes 3. Value of I becomes 2. Is 2 less than equal to 2? Yes. 2 is not less than 2, but 2 is equal to 2. So the condition is true. It will come here. Put the value of 2. MSG2 means the character stored at index 2. Which character is stored? S is stored. So it will send S over serial communication, TXDP. It will wait till all 8 bits of ASCII code of S are sent. Once all 8 bits are sent, clear the flag. Now come here to the for loop for fourth time. Increment the value of I. I was 2, now it has become 3, and check the condition. Is 3 less than is equal to 2? 3 is neither less than 2 nor equal to 2. So means this condition is false. And this condition is false means come out of the loop. Don't enter the loop. It means that when all the 3 bits, all 3 characters of the string are sent, will come out of the loop. And then we'll terminate the program by writing while 1, which will act as a stop. It will stop the program here. Now I have made the changes in the program, so I will save the program. I will click the build on button and I will check for errors. Fortunately, there are no errors. Now we will start the debug session. So debug, start stop debug session. Click on the OK button. The serial window is here and it is still empty because I have not run the program yet. So I will click the debug and then I will hit the run button. Now as you can observe here that S is appearing in serial window. It means that the string S is sent over TXD pin of microcontroller and it is simulated in UART window. So this is all about the program to send the string S serially, but this program will send the string serially only once. In question statement it is asked that send the string continuously. So instead of writing while 1 here, if you want to do a particular thing for infinite number of times, then you have to write it in while 1 like we did in our first program. So include this for loop and all the logic in while 1. So I will modify it. I will write it in while loop. Now what will happen? The capital S will send once, then it will send twice, it will send thrice, and this process will go on and on. So these 3 characters are sent one by one in a continuous fashion. So let us debug the program and let us observe the result whether it is really appearing or not. Click debug and then click run. Now you can view that YES, 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 it is being sent serially at 9600 baud rate in a continuous fashion, means in a non-stop manner it is being sent. So this is all about the transmission, serial transmission of 8051. In this video lecture we have gone through 2 different programs. In first program we developed the program to send a single character capital A in a continuous manner, and in the second program, means in this program, we have sent the collection of character, that is string of character. Here we have sent 3 characters S again in a serial fashion at a particular baud rate in a continuous manner. So thank you very much.